For problem 6 of exam 4, parts A and C, we are following and evaluating the indefinite integrals. First, we can break this fraction up to 2 parts, and then it will grant us with negative 2x plus 1 over x. Using each of these individual terms, we can then distribute the integral to each of these terms using its property. This gives us integral of negative 3x to the 8th dx plus integral of 5e to the x dx minus integral of 2x dx plus integral of 1 over x dx minus integral of x to the 1/2 dx. Then we evaluate each of these individual integrals in order to solve one and all of them together to get one final solution. Also remember to keep a note that square root of x is equal to x to the 1/2. For the first term of negative 3x to the 8th, we can simply use power rule. Negative 3x to the 9th over 9th. Plus, then next we have an exponential form. The antiderivative of e to the x is just e to the x times its constant 5 plus 5e to the x. Next, we have 2x, which can simply use power rule again. Then, for integral of 1 over x, we have to use the log properties. In this case, natural log of absolute value of x minus the integral of x to the 1/2, which can use power rule once again. Plus c. Then we simply simplify, and then that grants us our final solution. This is then our final solution. Next is part C. Unable to break this integral down, we have to use u substitution. So first, we pick our v value, which in this case is x squared minus 4, and can be easily identified since it's a function within another function. So then, thus, let u equal to x squared minus 4. Derive that, giving us du, gives us 2x dx. Therefore, our dx is equal to du over 2x. Keeping that in mind, we can then implement that back into our function. Integral of x cubed times u to the 5th times du over 2x. We can cancel out an x from here and here. Then we can also carry this 1/2 out in front of the integral since it is a constant, giving us 1/2 integral of x squared times u to the 5th du. We're left with this x squared. So, in order to get rid of that, since we can only have it in terms of one variable, we can use this equation in order to find what x squared is equal to. And we can simply do this by plus 4 on both sides, granting us x squared is equal to u plus 4. Implement that back into our equation. We are left with u plus 4 times u to the 5th du. We can then simplify that by using the distributive property, u to the 6th plus 4u to the 5th du. Then, through the use of power rule, we can finally integrate 1/2 times u to the 7th over 7 plus 4u 6 over 6 plus c. Simplify once again by distributing 1/2 to each of these terms, giving us u to the 7 over 14 plus u to the 6 over 3 plus c. Then put our u's back into the equation, giving us x squared plus 7 over 14 plus x squared minus 4 to the 6 over 3 plus c, giving us our final solution. And here are our final solutions to A and C of 6.